Good morning, everybody. Welcome to this presentation. I'm going to be talking about the importance of moisture control and measurement throughout the production processes in the mills. As Roger said, my name is Neal Cass and I'm Sales Manager from Hydronix, a UK-based leading manufacturer of precision moisture measurement equipment using a specific digital measurement technique. So if I can get this to work. Oh, there we go. So why do we want to measure moisture? So grain is a natural product and the other materials that we're using. And so the moisture in that bulk material will vary depending on a number of different sources. So different growing conditions, different harvest environments, what the weather's doing when you're taking it from the fields during the cutting and the threshing, and then the storage environment itself. So this is critical for processing because different moistures affect the performance of the machinery. So the material plasticity and the malleability, and also the final product quality. And it's important to have the correct moisture level in the feed, as too dry makes the product difficult to digest, and too wet means that you're just wasting the water and makes it prone to molds and spoilages. Finally, by knowing and controlling the water content at each step of the process, you get a lot of stability in the process, which makes it a lot simpler to control. And this enables you to improve the efficiency, to reduce your carbon footprint, and also to save money. So just to summarise, by putting in a repeatable moisture control system, you can get a higher yield from your material, you can get higher quality feed, you can get higher profitability from your whole process plant, at the same time as reducing the waste from your materials and your systems, reducing the energy consumption of your plant machinery, and finally reducing the carbon footprint of the final feed. So where can we measure moisture? So there's a number of different areas around the plant where it's important to keep that moisture under control. And different measurement and control methods are suited to each individual area. If we look at the intake and reception area, the transfer to the storage and any raw material drying that happens during the intake, this allows the materials to be managed as the temperature, moisture and humidity are all key factors together in things like mycotoxin contaminations and growth, which can lead into short storage life of the grain and can also cause problems in the storage silos like hotspots, even resulting in catching fire. If there's a drying stage in the process, it's also very important to control that, to measure and control the moisture during the process to prevent any damage to the material itself through over drying and also wasting energy, leading to cost and other environmental concerns. In the grinding stages, measuring the incoming flow of material allows you to control the water addition during any conditioning and tempering stages, and this allows you to get the correct moisture for efficient grinding. Moisture affects the elasticity of the material, which in turn affects the particle size you get from your roller and hammer mills and causes other problems like dust and cracking, and finally increases the energy used by the mill. So if you have the moisture correct, you can control the mill efficiently. After milling, during the mixing stages, it's important to measure as the materials are being weighed in the dosing systems, because the weight of the water in that material will affect the amount of raw dry material you have going in, and it's the mix of the dry materials you want to be correct in your final feed. So it's also important to measure the moisture level in the mixer itself so that you can achieve the final moisture content of the mash, so you get the right amount of water in for the next stages, such as pelletization. So during pelletization and extrusion, obviously if the water or if the moisture is too high, then this can cause the pellets to be poorly shaped or sticky and can cause a lot of friction in the pellet mill, increasing the energy, causing blockages, and sometimes even causing damage to the die if you have a bad blockage. It's not being maintained. If the moisture is too low, then this can lead to badly formed pellets and pellets that fall apart and increases dust and leads to higher machinery wear. And finally, in the bagging or packaging areas, it's important to know the final moisture as a final product quality check. So there we go, back to the main thing. So how do we then measure the moisture? So knowing the moisture online rather than offline allows your operators and the control systems themselves to react quickly to the changes in the material. And this will give you a full knowledge of the material moisture whilst it's flowing in the process, and allows you to react fast, to give a fast reaction to the moisture changes. It also gives you an accurate representation of the total flow, of the total moisture in the total material, and not just at a single point. So to just demonstrate this, if we take a moisture trace from a grain intake system, this might vary as we go along between, you can see, between 19 and 25%, so it's going up and down all the time. If we take 3 samples from that process, then those samples could all be at the high spot. So we would get an incorrect sample average from those 3 samples. You can see here it would be about 24%. If we take the average from the actual moisture sensor, which is online and reading all of the material moisture as it goes past, obviously we can see that is now giving us 22% average moisture. So you can see a difference of 2% over what you would have used as a set point. So there are different ways of measuring moisture, so I'm just going to explain each of them so we can compare different types of sensors that are available on the market. The first we'll go through is NIR or infrared sensors. So these tend to be higher installation and ongoing maintenance cost, and also only give a surface reading, which can be affected by changes to the material colour, the dust, and the ambient temperatures. And this is all due to the way that the measurement technology works. It is a visible technology. This can be offset against the ability of the NIR system to get other online measurements from the sensor, such as protein and fat contents. And these can be very beneficial for controlling the formulations, but that only tends to be during the mixing stages. Resistive and capacitance sensors both use an electromagnetic wave at low frequencies to work out the electrical properties of the materials, and this is then related to the moisture. But because of the technology, they can be affected by the sorts and material changes, and also density changes in the material, as well as temperature, which makes them very sensitive. Older style microwave systems also use an analog technology, which is similar to this. It does have a good reaction with the water in the material, but there's a non-linear relationship, and due to the way the measurement is being done, and they are also affected by temperature, salt and density changes, which make them a bit more unreliable. Nuclear sensors are very expensive, and whilst they give a very accurate measurement, that measurement is of a full storage silo or a large space, and they're not really suitable for smaller ducts or conveyor systems. They also need very specialised staff and with qualifications and regular certification to look after the nuclear sources that they use. Finally, the digital microwave measurement technique sensors use a specific measurement which is linear inherently by design with the moisture change in the material. They are very stable over both time and temperature, and they are very simple to install, to calibrate and to use. They do just need a good consistent flow of material to measure in, but this can normally be achieved by good mechanical design and selection of the correct location for them to work in. So I'll just show you a quick case study of a grain dryer which is being improved by addition of a moisture sensor. So to show this, we look at the input moisture being measured, and the dryer temperature is automatically controlled to optimize the energy input for the moisture level. So we're preventing over drying of the material. So we can show this by calculating the energy requirement of the dryer. We'll assume 100% efficiency, which, although not practically achievable, it does give you an idea of what the savings can be. So if you start from 20% moisture and you're targeting a 14% moisture feed from the dryer, if you only have a measurement accuracy of plus or minus 1%, then you actually need to over dry to dry down to a target of 13% to make sure all of that moisture is removed. So this means that you're removing 7% of the moisture. And we can calculate that at being around 46 kilowatt hours per tonne of material being made. If we can then improve that to plus or minus 0.5%, which is what you can practically achieve with a good, well-installed moisture sensor, we can then look at reducing that amount that you're drying to 6.5%, which means that the energy you're using now drops to about 42.5 kilowatt hours per tonne. So a reduction of about 3.3 kilowatt hours per tonne, or 7%. If we then look at a 16-tonne batch example, there's 3 different things that you get from that. The first is you get a higher yield. Because you've got that 0.5% extra, you're getting an extra 80 kilograms of final material out of the dryer. We're looking at a lower energy cost, so you're actually making, and I'm sorry about the use of UK currency, but a £15.84 saving in that energy cost you've used, and that's based on the current UK market prices, but a conservative value. And you're also reducing the emissions. So if you consider that each kilowatt hour is creating a certain amount of CO2 emissions, so I've taken the UK national grid statistic of about 0.193 kilograms per kilowatt hour. You can reduce your emissions by 10.2 kilograms of CO2 equivalent per tonne being manufactured. For the 16-tonne batch, per batch. So one thing to consider when you're looking at moisture sensors is how they're calibrated and connected to the control system. So all sensors need to be calibrated, and obviously the best use of them is to connect them. And the easiest way to achieve that is by sensors that have good connectivity and interface options. So we can see here an example of a sensor network interfaced through a centralized hub system, which allows you to connect to the system via a web browser to then do the calibration. You can also display sensor values from a central location. And then there is options for connecting to both the control system via analog outputs and Profibus, Profinet, Ethernet IP links, field bus, and also Ethernet, which allows you to get onto networks or even onto the internet to then, I've only got a couple of slides left, to then allow you to gather data from the system and to use it more widely. If you have a number of locations or even a number of locations in the same plant, you can connect your locations together with a well-designed system. So just to bring this all to a conclusion, I've just explained why do we measure moisture? So we measure moisture to react to the changes in the moisture, which gives us the overall benefits of energy, cost, and the environmental impact. Where do we measure moisture? We can measure at a number of different locations, but it's important to make sure that we put the right mechanical installation methods in. And how do we measure? So we would always recommend using an online measurement to make sure that you've got a continuous reaction to the change, and having sensors which have good connectivity to them. And thank you for listening. We're at stand J21. If anyone has any questions or wants any information, then please come and find us.